So, let's start out with number one, finding the constant of proportionality. This is just like we talked about in our warm-up. K is the exact same thing as slope, except with only proportional relationships. So all we need to do is find the change in x and the change in y. On the top, from 2 to 3 is plus 1. From 3 to 4, that's plus 1 as well. On the bottom, from 8 to 12, that's plus 4. And from 12 to 16 is also plus 4. K is equal to y over x. Remember the phrase, why aren't you over your x? Just to prevent yourself from accidentally putting x over y. Our y that we found was 4. Our x that we found was 1. 4 over 1 simplifies to 4. That's all we have to do to find our constant of proportionality. Now, if you want to, because we know this is proportional, we could just take any of these 3 points and just put y over x, right? Y over x, if we take the first point, 8 over 2, 8 over 2 also just simplifies to 4. 12 over 3 simplifies to 4. 16 over 4 simplifies to 4. Because this proportionality is constant. That's why we call it that. Each of these points will work, but the change in y over the change in x will also work, just the same. K is equal to 4. Now we also have to write an equation. The formula for this equation is y is equal to kx, just like Yo Mama's ex-boyfriend, but instead of a mama, it's a K. So Yo Koala's ex-boyfriend or something, and there's no B on the end. So all you do is take the K, plug it in for K. Y is equal to 4x is the equation that we can write there in number 1. Quick show of thumbs. Was anyone able to get number 1 all by themselves? Get 4? Good. Maybe with the help of your group. Either way, that's great. Okay, please make sure you're writing this down as we go. I don't have time to walk around and make sure we're all on task, so the trust is in each of you to be doing what you need to be doing right now. Over to number 2. Similar but different, because now this is a non-proportional relationship. We can see in this very first point that we don't pass through the origin. If we did, we'd see 0, 0. Right, but we see 0, 4 instead. So we're going to find the rate of change, that's just fancy term for slope, and write the equation of the line. Same exact process. From 0 to 3 is plus 3, from 3 to 6 is plus 3, from 4 to 9 is plus 5, and from 9 to 14 is plus 5. M is equal to the change in y over the change in x, which gives us 5 over 3. Can we simplify 5 over 3 at all? No, we can't. B is the point in which x is equal to 0. So if our x coordinate here is 0, whatever number corresponds to that 0, that's going to be what b is equal to, in this case 4. If we plotted the point 0, 4, 1, 2, 3, 4, we'd go 0 spaces left and right, 4 spaces up. That right there is the y-intercept, because it's where we intercept the y-axis. So whenever you see x and a 0, red flag should go off in your head, and you should be like, oh, that's my b right there. b is equal to 4. So if m is 5 over 3, b is 4, all we have to do in order to write this equation now is follow the formula. Y is equal to mx plus b. Substitute out the m, substitute out the b. Y is equal to 5 over 3x plus 4. And that's the equation that we can write there. So like I said, 1 and 2 are very similar. The only difference is number 1 is proportional, number 2 is non-proportional. As we saw yesterday with that activity with the whiteboards, the only difference is our y-intercept. Proportional relationships have a y-intercept at 0, which is why we don't see a b value on the end. Non-proportional relationships have a b value that is not 0. It could be 4, it could be -2, it could be anything but 0. That's why we see that number being added on the end. That's our plus b in the formula, our slope-intercept formula. All right. Questions I can answer about 1 or 2 real quick. I know some of us had some questions I didn't get to get the chance to answer. So if something doesn't make sense or you need further clarification, please feel free to interrupt me at any time. Down to number 3. Again, we see, hey, this line goes through the origin. This is a proportional relationship, and plus it even says proportional relationship. So if we want to fill out this table, all we have to do is line up each of these points. Now, what are we talking about in this problem? We're talking about water use. Our units are gallons per minute, right? Gallons on the y-axis, minutes on the x-axis. Good morning. So if we zoom in on this graph, we can see the x-axis is going by ones. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank you. Did you get this worksheet yesterday, 19? Yeah. Okay, perfect. Go ahead and take it out. We're going over it right now. We're on number 3. But our y-axis is not going by 1. Our second notch is 10. So what would this first notch be? What number would that first notch be? Anyone know? 5. Just 5, right? Each notch is 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So now we just got to figure out each of these points. After 1 minute, that's this point here, after 1 minute, we see that 5 gallons have been used. Okay, after 1 minute, we look up and over, 5 gallons have been used. After 2 minutes, 10 gallons have been used. After 3 minutes, 15 gallons have been used. And then we make a big jump, right? And someone pointed this out, which was awesome to see. We jump all the way over to 7 minutes, in which 35 gallons are used. Then we make another leap. At 10 minutes, 50 gallons are used. So this table doesn't include each amount of minutes. Some of you may have seen that if you do your change in x, you get +1, and then +4 and +3. Now typically when we see something like that, our brains tell us, oh, this is not going to work out. But because this is proportional, if we were to set up each of these fractions as ratios, it would look something like this: 5 over 1, 10 over 2, 15 over 3, 35 over 7, and 50 over 10. Y over x. Hopefully you can notice each of these equations, or not each of these equations, each of these fractions are proportional, and when we simplify them, what would we get? 5. So that means that my k is equal to 5. For the equation, if y is equal to kx, in this case, y is equal to just 5x. So however many minutes pass, you could multiply that number of minutes by 5, and that gives you the number of gallons. And that makes sense based on what we see in the table. 10 minutes multiplied by 5, 50 gallons. 7 minutes multiplied by 5, 35 gallons used. So there's our proportional relationship in number 3. Like you saw on the agenda, our focus is all about K today because it's been so long since we've talked about it. But hopefully you see that it's basically the exact same thing as finding slope, right? If we did rise over run from this point to this point, We're rising up 5, 10, 15, 20. Running over 1, 2, 3, 4. 20 over 4 would also give us 5. So everything is connected. Graphs, tables, fractions, y's and x. I know it's a lot for us to take in, but hopefully we've built that solid foundation as we've gone through each of these blue papers. There's number 3. Down to number 4. This is essentially the exact same thing we did with our whiteboards yesterday. I would hope that all of us were able to do this on our own yesterday, because I saw so much success with those whiteboards in identifying whether it's proportional or not. So 4a, we've got y is equal to 6x. Real quick, give me a thumbs up if this is proportional, thumbs down if you think it's non-proportional. This one, first one, 6x. Good, I see all thumbs up. This is proportional. Now on the test tomorrow, you're going to be asked to explain how you know this is proportional. So what would you be able to say about A, Devin?
B equals 0.
That's right, because B is equal to 0. What does B equals 0 mean, though? If we were looking at a graph, what would that mean? That's right. B is equal to 0, so it goes through the origin. If you just put because B is equal to 0, that's great that you identified that, but that doesn't really explain to me that you know what's going on. So you have to mention that it goes through the origin if you want the full credit for that. 4b, thumbs up proportional, thumbs down non-proportional. What do you think for 4b? All thumbs down. That's right. This is non-proportional. And what can you say to explain why this is non-proportional? B doesn't equal 0, right, Devin? So what does that mean? That's right. Doesn't go through the origin. Where does it go through on the y-axis? -1. Goes through -1. -1 is not the origin. The origin is 0. So that's why that one's non-proportional. And finally, a graph on 4c. This is very obviously non-proportional. We should be pros on this now. Not through origin. I'm just abbreviating it. You're going to have to write a full sentence, but we don't have time to be writing out sentences. There's our proportionality in number 4. Down to 5. Does the table below have a constant or non-constant, also known as variable, rate of change? Now, this is something that we haven't directly taken notes on, but if you use the process that we are familiar with, it's pretty obvious whether it's going to be constant or not. So on the x's, we're going to do our arrows. From 1 to 2, that's +1. From 2 to 3, that's also +1. So far, so good. From 5 to 10, that's +5. From 10 to 20, that's +10. Is that a constant change in y that you see on the bottom? No. One of them is +5. One of them is +10. Right? We can't put 5 over 1 and 10 over 1 and get the same number. This is not constant. One more time. Yep, that's all you got to do to show your work is the arrows. You recognize, hey, those are different numbers. This is not constant. Yes?
So if they were constant, then they would be the same?
Absolutely. Let's look at number 6. From 6 to 4, that's -2. From 4 to 2, that's -2. From 17 to 11, that's -6. From 11 to 5, that's -6. Everything constant there on the top and the bottom? Yeah, we got all -2's on the top, all -6's on the bottom. This would be a constant relationship. What would, I know it's not asking this, but what would the rate of change or the slope be in number 6? -6 over -2, right? Which would be equal to what? 3. Thank you, Francisco. 3. So when we have a constant change in y over a constant change in x, We can simplify that to get a number. But over here, 5 over 1 is equal to 5. 10 over 1 is equal to 10. Those are not equal, so it is not constant. Does that make a little sense? Question, Devin? Or no? Okay. Questions on the front before we flip over and do some graphing type stuff. Give me a thumbs up if that all sounds good to you on the front. Good. All right, over to the back. 7 and 8. This is a bit of a deep cut. We haven't talked about the slope formula in a while, but I'll write it up here so we can remember. M is equal to y2 minus y1 over x2 minus x1. Now, when we use this formula, the first thing we have to do, does anyone remember what the first thing we have to do is? Starts with an L. We got to label each of these numbers with each of these variables from left to right. x1, y1, x2, y2. Again, all this does is signify that it's our first x-coordinate and our first y-coordinate, then our second x-coordinate and our second y-coordinate. It's not an exponent, it's just telling us the order. So now we just got to plug each of these in. M is going to be equal to, if you remember our setup, parentheses minus parentheses over parentheses minus parentheses. What number is going to get plugged in first here? 7 minus what? 2? 3. Y1 is 3. And on the bottom we've got 10 minus 2. 7 minus 3 on the top gives us, I think, 4. And 10 minus 2 gives us 8. How can we simplify 4 over 8? 2 and 2. Well, if we've got 4 times 1 over 4 times 2, what can we cancel? What are we left with? 1 over 2. So don't get too quick and be like, oh, 4 goes into 8 2 times. My answer is 2. No, you got to keep it as a fraction when your smaller number's on top.
Wait, we don't start with X first?
What do you mean? Like here?
Yeah, like we don't, the other way around.
No, it's y2 minus y1. The y's always go on top. The x's always go on bottom. Remember, y aren't you over your x, y over x. If we take a look back at this lesson, let me see if I can even find it. The slope formula. These are our first period notes from September 19th. Y is on the top, x is on the bottom. And remember, you have access to this during the test, okay? So if you're like, oh, I forgot what the slope formula is, just look through your notebook. Everyone took these notes. If you weren't here on one of these days, all the notes videos are in Google Classroom. You can get those copied down, okay? Because remember, I can't answer any questions during the test. You only have 15 minutes before you are completely on your own, aside from tutoring today after school if you want to come by and get some help. So number 8, same thing. We're going to label our points. x1, y1, x2, y2. M is equal to parenthesis minus parenthesis over parenthesis minus parenthesis. And we have to be even more careful with this one because we've got negative signs. That's going to make things a little bit more difficult. y2 minus y1 is negative 6 minus 2. x2 minus x1 is 7 minus negative 1. What would negative 6 minus 2 give us on the top? Negative 8. Good. Now what happens when we have two minus signs right next to each other like this? What do they form? They make one big plus sign. What's 7 plus 1? 8. Now 8 over 8, that's easy. That simplifies to 1. But what's a negative over a positive going to give us? A negative. Our slope there in number 8 is negative 1. So I wanted you to have an example of a fractional slope and a negative whole number slope. It's not a whole number if it's negative, but you know what I mean. Negative integer slope. So this next one, number 9, comes from worksheet 16. I think it was last Monday we did it, a week and a day ago, 8 days ago. All you got to do is identify the M and the B. As long as you remember the formula, y is equal to mx plus b, or yo mama's ex-boyfriend. So in A, y is equal to mx plus b. M would be 3, and b would be positive 4. That's all you have to do, is identify, that means look for and write down your M and your B. In the second one, y is equal to mx plus b. Y is equal to 3 over 4x plus b. 3 over 4x minus 2. M is 3 over 4. That whole fraction is our slope. The top is our rise, the bottom's our run. And b is going to be equal to 2. Right? Good catch. Negative 2. I was going to see if anyone could see that. Whenever we're subtracting, our b has to be negative. All that means is that we are crossing the y-axis below the origin in our negative space. Now C, it looks like I'm missing some information here in number C. What number is really in front of that x that we just can't see? 1. And if we don't see anything added on the end, what is it? 0. Good. You guys know what I meant. So M is 1, B is 0, M is equal to 1, B is equal to 0. You don't have to put this in a fraction. We only need to put it over 1 if we're going to graph it, which we will do, not on this, but you will on the test. We already have a fraction in 13. Now, numbers 10 and 11 I had some questions about because we didn't actually have a worksheet on those, but it's the reverse of number 9. In number 9, we started with the equation. We had to extract the m and extract the b. But in number 10, you're given the m, you're given the b, and you have to create this equation. So you're just working in the opposite direction, but it's the same thing. What's my m equal to in number 10? Negative 5. What's my b? Is it 0? It's 3. And I had a good question earlier. Well, what do we do with this 0? Nothing. All that 0 tells us is that this point is on the y-axis. So whatever the number is, if we look back right to number 2, that x being 0 doesn't mean anything to us. We're focused on the y value that's underneath it. That gives us our b, which is 4. Yes, we have to put it in slope-intercept form. Y is equal to mx plus b. Y is equal to negative 5x plus 3. Whenever you're asked to write the equation, that means slope-intercept form, yo mama's ex-boyfriend. And number 11, same exact thing. M is equal to 6 over 7. B is equal to negative 10. Yo mama's ex-boyfriend. Y is equal to 6 over 7x minus 10. Yes. Yep. On number 10 or number 11? There's number 11. All right. If you're not feeling too great this morning, don't forget this is being recorded. It'll be in Google Classroom by the time you get home today. So you can always study this worksheet tonight. Review some of these problems that maybe you had your head down for or something like that, and get this all copied down and understood before we take our test tomorrow. Because we're also going to turn this in tomorrow with our test, just like we always do. Down to 12. Find the slope of this line. It gives you a nice little hint. You won't have this hint on the test, So just make sure you understand how to do rise over run. Which point should we start with? This blue point or this red point? We're going to start with our leftmost point. And are we going to count up or down? We're going to count up. 1, 2, 3 spaces up. And then 1, 2, 3, 4, 5 spaces to the right. M is equal to rise over run, which in this case is equal to what? 3 over 5. That's right. 5 over 3 would be incorrect. You have to remember rise over run. Think about it like this. Like I said before, you have to rise in the morning before you can go on a run. So rise over run. That's how we're going to find the slope of that line. Before we get to 13, I want to talk about 14 because 14 is connected to 12. 14 says identify the y-intercept of the line in number 12. Well, where does this line cross the y-axis? At 3. Boom. Right there is my y-intercept. So B is equal to 3. Now, just like we did in number 10, if M is 3 over 5 and B is 3, we have to write this equation in slope-intercept form, which is y is equal to mx plus b. What's this equation going to look like? That's right, 3 over 5x plus 3. Boom. Unit 4, when we come back for term 2 on Monday, is going to be all about writing equations. It's basically going to be a continuation of what we're talking about right now, so please don't forget everything over the weekend. Now we can go back up to 13 and graph this equation. Remember, there's 6 steps. 4.3, it's our most recent lesson. We got to start by identifying M and B. Negative 7 over 4. B is 5. B is where we begin. What direction should we rise 7 units? Are we going to rise up or down? We're going to rise down. How do we know we're rising down? Because it's negative. And what direction should we run? To the right. Always to the right. So we're going to make our first point at positive 5 right there. We're going to go down 7 and right 4. 1, 2, 3, 4, 5, 6, 7, and right 1, 2, 3, 4. Make our second dot and draw our line. Everyone's going to get some scratch paper and a ruler tomorrow during the test so your lines can be nice and straight. If you opt not to use your ruler, I'm going to take a point off. I want to see straight lines. I've emphasized that before. If you want to come in and do some wobbly line like that, that is not a linear equation because linear means straight line, right? So that is not going to be accepted. Everyone will get a ruler, so there should be no excuse. Just connect those points with a ruler. That's our line. From left to right, we see we're going downhill. That's perfect because our slope was negative. And we intercept the y-axis right there at positive 5. And last but not least, before we're out of here, number 15. What type of relationship is this? Linear. Good. What else? Proportional. Proportional. So if we're going to find the unit rate is just the same thing as slope. We could do rise over run. Or, because it's proportional, we could say k is equal to y over x. There's a point right there where the y value is 60, the x value is 1. So we can say k is equal to 60 over 1. But what are my units on 60? Is it 60 cars? 60 families? 60 miles. What's the unit on my 1? Hours. So we could say that the unit rate here, K, or we could say M, either one, is equal to 60 miles per hour. If you don't have the units on your answer, again, points will be taken off. If it asks specifically for the unit rate, you see that word unit, you should think, oh, I need units. 60 is not enough. 60 miles per hour is what we want.